This lesson is on applied optimization, or how to find either the minimum or maximum values for a problem. There are a few basic steps that help solve these types of problems. First, read through the problem and write down all the important information. If it helps, draw a picture as well. With the information given, find what equations are related to solving the problem and set them up using the limitations also provided. Then replace those answers within the equation for solving the main question. To find critical values, derive that equation and test those points to find the optimized answer. Last, find the min or max by replacing those points back into the optimization equation. Here's an example for us to demonstrate this type of problem. You're moving to a different city and are trying to make the best use of a moving truck you've rented by getting boxes that will best fit the truck without wasted space. You know that a manageable box weight for your clothes uses around 250,000 cubic centimeters. To easy carry, you believe a box that is twice as long as it is wide will be best. What you want to find is the box with the smallest surface area that will still have the same volume. So first thing we're going to do is we have a picture here and we're going to label it with the information we know from the typical problem or equations. We have the volume equals the length, the width times the height, and the surface area will be 2 times the ends, and then 2 times the length times the height, 2 times the width times the height, and 2 times the width times the length added together. The next thing to do is actually replace in the information we have from the problem into those equations. So we know for volume we have 250,000 centimeters cubed. And then for the surface area, we have the same equation still. Now to find using the constraints, we need to put back into the volume equation. The problem here is that we have too many variables and we need to remove some of them to make this problem solvable. And we're going to pick h for the height to solve for so we can remove it out of our equation. Now since we know that the volume is 250,000 cubic centimeters, we'll actually use the 2x squared times the height, or the 2 of the width times the height, equaling the 250 centimeters squared, and solve out for h, which we get 125,000 over x squared. The next step, since we know what h is, we'll actually replace back in that sum into the surface area equation so that we only have one variable. Since we already knew that the length was 2 times the width, we've already replaced that in there as the 2x. And the answer to all that comes down to the surface area being the 2 times the width squared plus 750,000 over the width. Now to get the critical values, we actually have to derive that equation and then solve for x again, or x equals, or 0 equals that, to find out what the values are. And since we already know how to derive earlier in this chapter, or this semester, we'll just go to the answer, which is the s prime or the prime of the surface area, is 4x minus 750,000 over 2x squared. And we're going to go to the next step. We're going to equal those out to 0. Since they're multiplied by each other, we can split that up easily. And we get one part of it that x equals 0, and the other part of it that x equals the cubed root of 187,500. Big complicated number, so we're just going to leave it at that for this step here. We'll move on to actually check this with our critical answers and make sure that this is the minimum, which is what we were looking for this box. Now we'll put these answers, or we have since one of our answers was 0, we know that a length of or we cannot have a width of 0 of this box. So we're automatically going to assume that that's not in there, and we're going to use our second answer, the x equals cubed root of 187,500, or approximately 57.24 centimeters, to test this. We're going to pick two numbers, one on each side of this. We went ahead and picked 25 centimeters and 75, making them easy numbers to work with. So on the left side, working through that equation, putting it back into our derived formula, we get a negative 100, or a negative 1100. Since that's a negative number, we went ahead and put the downsloped arrow to signify that that curve of that would be going downward. On the other side, using the 75 centimeters, we actually get an answer of 166.7. Being a positive number, we have a positive arrow, or positively sloped arrow, representing the fact that at that point the curve would actually be going back upwards. This actually represents, at that point of the cubed root of 187,500, is a minimum. Whether it's a global or it's actually a global in this case. It could be a local in another case, but it is a minimum. So what we're going to do next is actually put this back into our original finding. Since we know that x is simply the width, we go on to the length, which we knew was 2 times the width. So we end up getting an approximation of 114.48 centimeters. And we knew that the height was 125,000 over the width squared. And we get 38.15 centimeters for that. Now, putting those back into the volume equation, we do get a slight variance in there of 249,990.6629 centimeters cubed, which is only off by a small margin. When you actually put in the values for the cube root of 187,500 into the equation instead of the approximations, you do come out to the answer of the original volume assumed of 250,000 cubic centimeters. So our final box that we were looking for is, we found the surface area, but the dimensions itself would have been the 38.15 centimeters, approximations of course, height the 57.24 centimeters, and 114.48 centimeters in length. After this example, hopefully you are better able to solve for optimization equations. If you do need more resources, of course your textbook is a good place to start. There are other YouTube videos out there, better YouTube videos, honestly admitted, and as I say here, if you are very, very desperate, you could always go up and ask your professor any questions that you have on this type of topic. They probably will give you answers. Hopefully you'll understand them. If you don't, you can always go back to YouTube again and find more videos.